Okay, so today we'll be first talking about modules in Python. And essentially, what modules are by definition, it's just a file that contains Python code, right? But think of it as like a sort of library. Like you can import these files and use them in your code. It's like pre-written code that you can use, and you get this code from a library. So modules can do a lot of useful stuff, but in order to download some of these, we need to use something called pip, which stands for Python install package, which is the most popular package manager for Python. So if you want to use external modules that aren't part of the standard Python library, use pip. You can download the latest version at this link. So one of the most popular libraries is Numpy. So essentially, what Numpy is it's used a lot in enterprise level software. It's used a lot in heavy math or machine learning related softwares by major companies such as Google, Microsoft, Facebook. So, as mentioned earlier in camp, there's no native support for arrays in Python. So, that's the root issue that NumPy wants to address. So, to solve that, we use NumPy, which has its own implementation of the array. Python itself has kind of a similar thing to arrays, which is the list, but NumPy actually gives you essentially as close as you can get to native support for arrays. And these arrays can be really powerful in a wide range of math applications. So NumPy calls, well, first you want to install NumPy. So you can do this now or later if you want, but essentially to install NumPy, you go to your terminal, like the command prompt, and type in pip install NumPy, and it'll download it. Then at the top of your code, just write import NumPy as NP. NP just shortens the word NumPy. So that's how you get the NumPy library in your program. If you're getting an error when you use pip, that's probably because Python is not in your path variables. So just re-download Python and click add to path at the bottom of the Python installer, and that should fix it. Okay, so the way NumPy addresses the array problem is using what they call an ND array. So ND array stands for n-dimensional arrays, like 3, 1, 2-dimensional, even 4-dimensional if you want, or more. So it takes in a normal Python list as an input, and you can see here that you can create one by saying np.array, and then you put in the list of items you want, like a regular Python list, and that converts a Python list into an array, a NumPy array. You can do all sorts of really cool stuff with that. Um, so on the next slide, you get ND array attributes. So you can get some really cool information about these arrays. So for example, we isolated the most popular ones, like the four most popular ones, but there are a lot more than this. So I highly recommend that you research on your own time when you're free some of the other types of attributes or functions you can do with NP arrays. So the first one we'll be talking about is ndim. Actually, okay, the first one we'll talk about is size, which arguably is the most important one. So size just gives you how many elements are in the array. So my array in this code has two lists in it, and each list has three. My array dot type gives you the values, like the data types values in those lists. So it gives back in 64. The shape of the array, this one is really cool and it's often lacking in other languages. So ND array.shape gives you how many arrays there are or lists. And then the second coordinate is how many items are in each list. So you can see in my array, there's two lists of 3 items. So it gives back 2 by 3. Right. And that's often a good representation of real life math matrices. Like a 5 by 5 matrix in math can be represented in NumPy like this, and you can see all that information. And then ndim, go back. Ndim returns how many dimensions are in that array. So this would be a 2-dimensional array since there's an array of lists. There's like multiple, just different lists in the array. So if like one were an array here, it would be 3 dimensions. Okay, so for some math functions that you can do with ND arrays, the ones we'll talk about here are the most popular ones, of course. So you can add two arrays together, like matrix addition, which is one of the first things you learn in linear algebra. So like A plus B, you just add each one of these terms, like 1 plus 4 is 5, and that becomes the first element. 2 plus 5 is 7, that becomes second element of the new array, and just onwards. You can multiply them by a certain number. It's the same algorithm. Um, you can square root them. You can sum them. You can sum up each element of the array. So np dot array, we have 149, and then if you do sum, it'll be 1 plus 4 plus 9, which is 14. And you can also find the mean of them. These functions are really important or useful if you have a large set of data, like a really large set, like say 300, 400 lines of employee salaries, and you want to quickly find the sum and mean of them. You can just do that in one line of NumPy, which is really useful. You can also reshape these ND arrays by, yeah, you can reshape them by going a dot reshape, and then that makes B a 3D version of A. So you can see how at first it was just a line of numbers like 0, 1, 2, 3, 4, and that's a one-dimensional array. And then we tell it to reshape A to a 3D version of A with 4 elements in each sub array. So that outputs 0, 1, 2, 3 as one list, and then 4, 5, 6, 7 as another. And then it keeps on doing that until it gets through every item in the array. So that's useful if you want to organize data or really like, yeah, it's typically used for organizing data. Um, so another important feature of arrays in like languages like Java is indexing and slicing. And in NumPy, you can do that, which things like these are kind of missing from regular lists, like the whole sum, square root, like rearranging them in 3D arrays that you can do in other languages. So this is why we use NumPy. So indexing and slicing, you can use the brackets, and you can use the brackets and a certain number to get the element at that index. So like 0 would return the first element of A, which is just 0. B0 would return the first array in list in the array B. So for example, B0 print would return 0, 1, 2, 3 as a list, which is the first row of B. And also, I want to note that the first index in in a 2D array in NumPy is a row value, whereas the second index would be the column value. So, for example, right, so B0 returns 0, 1, 2, 3. But if you want to get even more specific, like the second element of the first array, you do B0 brackets 1 bracket, and that'll return the second element of the first array. Okay. Then you can also slice it, like remember in strings where you could slice strings and get certain portions of strings. You can also do that with the ND arrays. So it's literally the same format as we learned earlier in camp. So A bracket and then the first element to the last element, non-inclusive, using a colon to indicate that you're slicing. So A1 through 4 prints the second element of A, the third element, and the fourth element, and then leaves out the fifth element. Usually index 4 would be the fifth element, and it leaves that out. Remember that it's non-inclusive. And yeah, that's pretty much all there is to indexing and slicing. There's some other functions you can do with indexing, like 1, 2 prints out the third element of the second row. So yeah, and then for outputs, for the last one, you can do 1:1:3, which reverses it and prints out each element as a list of 3. So it splits it into a 2D array. Each array has 3 elements, and then it reverses it. So arrays are basically mathematical it's basically the computer's way of representing matrices in math, like how instant computers represent numbers or floats represent decimals. Arrays were created to represent matrices, and matrices are just lists of different data points. So NumPy allows you to do linear algebra with these matrices, which you don't have to have learned linear algebra like in college or high school, but essentially just know that it's math with matrices. Math with matrices. So you can do matrix multiplication by doing the dot product, which is the np dot dot, and then you put in the first array that you want to have multiply, and then the second array which you want to multiply by, and it'll return the dot product. And there's a whole formula for finding dot products, and it's a pretty complicated formula, but NumPy does it for you really easily. And again, this is really useful when you want to find multiply two matrices that have massive amounts of data in it. Like massive. It'd be almost impossible to do it by hand. So you can do it in literally one line of NumPy, which is really cool. And this is especially important as machine learning algorithms essentially use a lot, like their whole algorithms are entirely based on linear algebra, because it just takes in lists of data and then tries to learn from it using if statements. So on the next slide, we get random numbers, which NumPy provides a suite of functions for generating random numbers. And this is actually better than, say, what you would get in the Python math module with math.random. So NumPy gives you a lot more options to do it. So you can do random distributions, permutations, and more. So, okay, the first thing you should know is how to generate a random number, which is you do it by saying np.random.rand. And then that gives you random numbers between 0 and 1 as a float. Pretty sure? Yep. And you can round that float to an integer to get a specific number if you want. So np.random.randn generates random numbers from a standard normal distribution. So like from -3 to 3, like 3 standard deviations to the mean, which is 0 standard deviations, to -3 standard deviations. So you can get something like 1.76, which would be a z-score. And this is pretty useful if you're working with statistics and you want random data points in a normal curve. And those are the basics of NumPy. Essentially, it's just used for math and linear algebra and for having native support for arrays. So Tkinter is another module in Python that is, I think, is one of the coolest modules in Python. It's a library in Python that allows you to make GUIs. And GUIs stand for graphical user interfaces. So essentially what that is, it's a type of user interface through which users can interact with their electronics via visual indicators. No, and this is the cool part. No installation with pip is required. Tkinter actually comes built in with modern versions of Python, like past Python 3. So the first part of Tkinter is creating a window. And to start a Tkinter program, first import the Tkinter module by writing from Tkinter import $TK. And we can create a window by creating a variable and setting it equal to the function tk parentheses. And essentially, think of this as like the startup function, the main function of Tkinter. It creates a window. And usually by convention, people call it root, but I like to call it window. And you can set certain properties for this window, such as its size by using dot geometry or icon using dot icon bitmap. Rithwin, move the slide. Yeah. So by using these functions, and you can see an example of some code here, like window.title app, geometry 500 by 500. It'll just make a big square. And then the icon bitmap, you have to insert a path to the bitmap file. And on the next slide, you can see what that code outputs. So as you can see, it's just a pretty clean Windows window with nothing in it. So to actually put stuff in the window, actually first, let's talk about the main loop function. So at the end of every Tkinter program, you must write app name, whatever you called it, .main loop at the end of your program. Essentially, the main loop keeps the application alive, constantly listening for events in the app, like key presses, mouse clicks, or window resizing, that allows Tkinter to know what to do with the information on the screen. So when the main loop is called, Tkinter enters a loop where it waits for events and then adds these events to a queue and then responds to these events. And without it, your program will simply not run at all because it's essential to even having a GUI. So to actually put stuff inside that empty window we created, we first can start by making a menu bar. So in Tkinter, in order to create a menu bar, you create a variable and set it equal to capital M menu. And then inside it, pass the name of the Tkinter window, like root or window. And then you can create an individual section of the menu by creating file menu equals menu bar, like what you call the initial menu bar. And then set tear off equal to 0. That just sets it on to the top of the screen. And then to actually add items, you can create dot add cascade, which labels the individual menu section as whatever you want it. Here in the code, it names it file. And then you can add commands to each of these menu items, and then command, and then new or new window, save as, open, exit, and add separator just adds a divider. And then active background creates like an active color. So if you hover over the menu item, it'll change colors. And you can make these commands actually do something by putting comma, command equals, and then some function. So you'd have to write the function by yourself and then pass it in. But if you do that and set it equal to the add command, set it equal to the command function and pass it into the add command function in file menu, it'll do that. So on the next page, you can see a better image of this. So it'll create a file menu. So first Tkinter will create a menu bar, and then it'll create the file menu, sub menu, and then in that file menu, it'll add the list of items like new, open, save, exit. So yeah. So that's the heart of many applications in Windows. But in order to actually place other items besides the menu bar, because Tkinter knows that menu bars always go on top of the window, but in order to create items that aren't necessarily for the top of the window, like if it's a label, it could go into the center or the top right or whatever. You can place that using .grid, .pack, or .place. My personal favorite and the one we'll cover is .grid. And the reason I say it's the best is because it gives you the most specificity with where you can place widgets into Tkinter. So here's how the system works. Imagine this as a window, and then the top left corner is 0, 0, and then the bottom right corner is 2, 3, which is like maximum amount. So if you create a button and then say dot grid x equals 0, y equals 0, it'll place it into the top left. And you can just use this as a reference with your own project, but I recommend using .grid. A lot of online tutorials use .pack, which you can use .pack. You can look more into it on your own time, but .pack I don't like it because it's not as specific. So the next slide is about the colors you'll use for these widgets. So if you want to create a widget, a lot of the time you need to specify the color or else it probably won't look good. So Tkinter gives you a lot of inbuilt colors, and the slide is kind of hard to see. So we can send out the slideshows to get a closer look. But essentially, Tkinter has a lot of built-in colors like snow, white, blue, a lot of shades of gray, black, pink, purples, everything you can think of. And each of these colors has a specific name. And if you don't type it in the program exactly how it is in its chart, it'll throw you an error. If you don't want to do all of that, you can just use a hex code, which is perfectly fine. So to actually create some objects, some widgets in these windows, the first one we'll learn about is a label. And a label is a really, like, it just labels something. It's just a piece of text that labels something. So to create one, we can say label equals label. You don't need the TK dot anymore. This is a bit of some old code. A newer code, you can just write label with a capital L, and the capital matters since Python capitals matter. So the first thing you want to pass into label is the name of the window. It's often called root, but I like to call it window. And then the text variable is a second parameter. It accepts, you don't have to fill in all of these parameters, but the most important one is the first one, which is which window it should be placed in. And then the second one, text variable, is essentially what text it should display. So you can see here that text variable is equal to text underscore bar. And somewhere else in the program, they probably said text bar equal to hello world to get that. Anchor is essentially another way to place items, but this time it's built into the label like object. So anchor you can say is equal to center in all caps, and that'll place it exactly in the center. Height and width in pixel is exactly what you think it is. It's the height and width. BD is the border outline. Font, you can pass in a tuple that is specified as a font. So Arial, the font size 16, and then bold, italics, or whatever. Cursor, you can change the cursor to hand too. There's a bunch of cursors in Tkinter that you can look up for reference that it'll change. Like you can change it to loading cursor, a selector cursor. FG stands for foreground, which is the foreground color. So you can set it equal to red or one of the other Tkinter colors we talked about. Pad X and pad Y is especially important because it specifies how big the label itself should be. So here it's pad X 15 and pad Y 15. That makes it 15 pixels wide. Pad X makes it 15 pixels wide in each direction, and pad Y makes it that tall. And yeah, that's essentially the important attributes for labels. And these attributes are used in pretty much all Tkinter objects, so it's good to know them here. Buttons are probably the second most important item that you can make in Tkinter. So to create a button, you just set it equal to button, and it creates a button object. Again, you get all like root to specify which window to place it in, text to indicate what the button should say. Command is specific to buttons because often when you click a button, you want it to do something specific. So command essentially equals some function that you write. So button underscore clicked would be a function that you write, and that'll do whatever is written in that function. Active background equals blue. So whenever you click on it, the active background should be blue. Active foreground should equal white. So this is active specifically means when you click on it and it'll change to blue and the text would change to white because that's a foreground. And you can see that in the GIF there. Anchor equals center. So it centers it in the place it is. So the difference between anchor and justify is anchor centers it in the context of the Y area it's already in. So for example, this would be in the Y coordinate of 0. So like the top of the page, top of the window, and anchor just centers it within that Y area. Whereas justify center would center it within the context of the whole window, like literally the direct center of the window. Again, you can specify font, height, highlight background, justify pad X, pad Y for width, height, and all that. So to place these items, you can do button.pack, pad X equals 20, pad Y equals 20. That's one way I would prefer grid by working. So the next most important item in Tkinter is scroll bars. So scroll bars in Windows applications used to scroll through large lists of items. So here they first create a list, which we can talk about here, but to create a list of items, you just set it to a list box object, and then you don't have to specify much. You can just say values equals these values. Or you can insert items into the list by using dot insert. So here in the code, they say for line in range, and then they insert an item into the list and append it with a unique number. So to create a scroll bar, you set it equal to scroll bar object, and the first item should be root, which is which window it will be placed in, and the root window is like the main application window. And then you can use .pack to place it. I would use .grid. And then the most important part is if you want the scroll bar to scroll through a specific list of items, you need to create that list. And then inside that list object, list box object, you need to pass in y scroll command equals the scroll bar name dot stat. And that'll tell Tkinter that it is specifically this list that I want the scroll bar to be placed in and scroll through. Without that, Python won't know where you want the scroll bar. And then the second most important thing is at the end, you want scroll bar dot config. You want to write scroll bar dot config, and the command equals mylist.yview. So command is like kind of the y scroll. It's kind of like the y scroll command. So it'll take the item that you want to scroll through, and then .yview gives you the vertical perspective. So y scroll command and yview gives you the vertical scroll bar, whereas x scroll command and xview will give you a horizontal scroll bar. And yeah, that's scroll bars. Remember .config and y scroll command. So another common widget object that you can create in Tkinter is combo boxes. So combo box, just create a combo box with a capital C object, the master, which is your window, the root, and then option. So option is an attribute that like a function value that you can pass into the combo box object, and value. And option basically takes in all of the values that you want in the combo box. So you can see in the picture here that the combo box is like a drop-down menu essentially with a list of items, and it has its own built-in scroll bar by default. And option equals a list of values. So here it would be the list of months. So for option, you can pass in like a list containing January, February, March, April, May, etc. And that'll create this. It's pretty useful in a lot of applications. You can also make input bars in Tkinter, and those are called entry, like an entry object. And of course, you pass in the parent as a first parameter. The parent, to remind you, is what you set equal to capital TK at the start of your program. And then there's some options like what we talked about earlier, like the font, the justify, anchor. Like this is placed in the top left, which is .grid00, or justify left, or anchor left. So you can specify like pad X, pad Y, which is how wide you want it to be. And yeah, essentially, this is pretty useful if you want to get input from your user. Like earlier in this camp, we learned about input from the command line, but here you can get it in graphical form, which is arguably probably a lot more useful. And yeah, so those are some of the most important widgets in Tkinter and how to mess with them and play with them and place them and make them look how you want. but these were only some of how many different options that Tkinter gives you. Like you can also make text editors, tabs, radio buttons, canvases in Tkinter, and in those canvases you can draw objects and shapes however you'd like it, just like you could on a real canvas. So there's a lot more items that you can look into in Tkinter. So make sure on your own time to do research into Tkinter on your own time, because Tkinter is a very vast library in Python. It's one of the biggest. It's one of not only the biggest but easiest to use at the same time. So it's really popular. There are also other modules that you can use to create graphical user interfaces in Python. For example, there's PyQt5, there's WX Python, there's a lot. So you can also look into those, and some of those offer features not offered in Tkinter, or they make their widgets look more accurate to actual windows. So that's Tkinter. Make sure to mess around with it, play with it, create your own Tkinter windows, and research into the different types of objects and widgets in Tkinter. Like there's a lot more. Like there's radio buttons, there's tabs. Like you can create tabs in your programs. Like there are tabs in Google Chrome. It's really cool. Just look into it on your own time and mess around with it. It's key to really learn it. Just mess around with it, create programs that do random things just for fun to learn all the different types of objects. And that's Tkinter and Numpy and Python modules. Um, since these are really complex modules and libraries, we don't have homework. And since it's the last day, we don't have homework. So, but we'd highly recommend that you just play around with the different functions and objects we told you about just to get a sense for them. Um, so yeah, that's the last day. We hope you learned something. We hope you were able to get